In this video, we will show how to calibrate and set up pulse channels on your VMAX 4000, specifically on the Model 4040 pulse input module. To begin, I'm going to go into the System Setup panel. And as I do this, I'm going to navigate to the Pulse/Speed tab input that we see here. And when I do that, you'll notice that for each 4040 pulse input module, we can accept up to 5 pulse channels. And those pulse channels could be used for something like a fifth wheel, a GPS speed sensor, an encoder, a flow meter. There's lots of different uses for our pulse channels. And the way that we set this up is in the top, we have our 5 separate channels where we can map those, we can turn them on for logging. We can set up a rate unit that we're interested in collecting in with appropriate full scales and number of pulses per engineering unit that we would expect to see. And then down at the bottom, there's a way, if we're using an encoder mounted to a wheel on a vehicle with a known tire circumference or a tire radius, we can turn that rotational speed into a linear speed. And then we also have the ability to do quadrature encoder stuff. So again, this would be for knowing position or using or for flow meters, for example. So there's quadrature where we only count, like rising edge. Then there's rising and falling edge. There's a couple of different options that you can select from here. So for my first channel, I'm going to set this up. A traditional sensor for us to use in this case would be a GPS speed sensor. So I'm going to start by selecting a speed channel that I would like to map to. This is not required, but is highly encouraged. I'm going to select channel 105 as speed, which is what we use for calculating stopping distance measurements, for example. When I select that, it's going to turn its log rate on by default to the fast rate, which is 1000 hertz right now. You could also set it to the slow rate if you like. This would not be advised at all on a precision GPS sensor. So let's go back to 1000 hertz. Okay, so next what I want to do is select what I would like to have my pulse unit read in. And the sensor that I'm using outputs 100 pulses per meter. And I would get that information directly from the manufacturer, or in this case with like a race technology speed sensor, that's something that you can adjust in the software directly. So you can make that really any number that you like. 100 and 400 pulses per meter are pretty common. Now I can also set the rate unit, and then we can associate a full scale with this channel. So you want to make sure that your full scale is set to something higher than you intend to measure. If you're going to go off 280 kilometers per hour, for example, make sure that your full scale is set to something that or higher. Okay, so I have my 100 pulses per meter has now been programmed in, and I have a signal generator that is connected to the channel 1 on the pulse input module, as I have circled on the photo to the side here. So what I'm going to do now is going to go ahead and start putting in a digital signal here. And as I do that, you'll see that we get essentially a speed signal that starts counting up, or that's increasing, pardon me. You'll see that we're counting the raw number of pulses here, and eventually you will see this roll over. I believe when it gets to 32,767, you'll see it go to negative 32,767, and it'll keep counting. Now, something else of interest that we could look at here is over on the right side of the screen. If I select the Show Totalizer or Distance and Angle channels, it's also going to show me, so in addition to looking at raw pulses and then a calculated speed, it's also going to keep track of accumulated distance for me. So in addition to like your channel 461 or my map channel 105, you also have these other channels in the 430 range that keep track of individual distance on each channel for you. And that's something that you could look at like in-stop distance or distance during a specific event, for example. Okay, so next what I would like to do on channel 2 is set up a wheel encoder that has a specific number of pulses per revolution, but I am not interested in looking at rotational speed. I'm actually interested in looking at linear speed. So to accommodate for that, what I'm going to use here is our encoder calculator. So I want to make sure that I'm selected on the channel that I want to set up, and this will be the second channel here. I'm going to go ahead and map that to one of my wheel speeds. And I know that this particular encoder has 1,024 pulses per revolution, and the radius of this specific tire is 15.8 inches. I'm going to go ahead and click apply. And because I have my pulse units in meters here, it's going to do this conversion for me. And it's going to tell me that I have essentially 406 pulses per meter coming from this encoder. Now, just like before, as I start providing a pulsed signal going into this, we'll see that we actually have a speed signal. We're counting our raw pulses, and eventually we will start accumulating distance here over on channel 432. Okay, and the next type of channel that I want to set up is I'd like to set up something to record engine RPM. So I have a sensor that provides 4 pulses per 1 engine revolution. So again, this is going to be a little bit different in that it's not a linear speed. I am actually interested in rotational speed. So I'm going to start by setting my rate unit here to an angular velocity of RPM. You see that I've got some error messages here because my pulse unit does not match. So I need to select a pulse unit that is angular position, which would be revs. Then I also have a totalized unit, which needs to match the same unit class as the pulse that doesn't match as well. So I need to select revs here as well. Now, once I do that, I need to enter in the number of pulses per rev that I expect to see. In this case, it's 4. And once I enter a value there, you'll see the error message go away. This will be corrected in a future software release. Okay, so after doing that, I need to also set my full scale. So in this case, the red line of the vehicle is 7,000 RPM. So I'm going to select 8,000 RPM as my full scale. And now as I start providing a pulse input signal, I'll see again that we're counting raw pulses, capturing the actual rate unit, and then as well as we're actually keeping track of total revolutions.